I'm going to now briefly explain this diagram of the low-pass filter. For our purposes, we're going to be using a low-pass filter of 12 decibels per octave throughout this tutorial, which corresponds to the center yellow line. This graph shows the loss of signal strength with respect to various frequencies. As we can see from this point back on the graph, there's practically zero attenuation. Therefore, there is practically no loss to the signal strength. This point corresponds to a frequency of 0.1 times 1 over the time constant. Therefore, if the difference in the signal and reference frequency is less than this amount, we will assume that it is completely unattenuated and therefore unaffected by the low-pass filter. This point corresponds to a frequency of 10 times 1 over the time constant. And as you can see, there is an attenuation of 40 decibels, which is equivalent to 99% loss of the voltage. Therefore, if our signal minus our reference frequency is of 10 times 1 over the time constant hertz or more, we will assume that it is completely attenuated or completely lost to the filter.